Welcome to this DynamicsCon presentation. Today, I am going to talk to you about doing some fantastic automation with Azure DevOps for F&O. Before we get started, I actually wanted to talk about my goals and why I'm doing this session. Clearly, with this conference, a lot of great community resources. There's blog posts out there as well, but I know in this conference specifically, there's going to be sessions about release management, build pipelines, RSAT. I don't know if they're specific about RSAT automation, but still a lot of great features. My goal here for today is really to show you that none of these features just stand on its own, right? What we're trying to do with Dynamics in general is we're trying to come up with features that are more like any other cloud product, right? We're trying to standardize, trying to become more mainstream. And as such, that also means that a lot of these new features you can start combining into existing cloud products and cloud features of Azure and Azure DevOps and other products. So what I want to show you today is that if you start including Azure, Power Automate, Azure DevOps, you can actually start leveraging these things and putting them all together in a big chain. And I'm hoping that by the end of the session, you'll actually start getting some ideas of making these things work and coming up with your own type of workflows. The main goal here is to show you that we can't possibly document all the use cases for these features of F&O and automation, just because there will be too many. We're probably not going to talk about all of them. That's why this session is kind of unique. I don't think we've ever done this sort of, and actually had a lot of fun putting this together. But we've never really talked about putting all these things together outside of just the F&O realm. And obviously, there's probably going to be things that you could possibly think of that we have never thought of doing, right? So I'm hoping to spark some ideas in you to show you how you can actually put some of these things together. And I'd love to see maybe the next conference or next blog post that you produce, what you've come up with specifically. Right. So what I'm going to do today on the agenda, it's pretty simple. I'm just going to do Azure DevOps demos. That's pretty much it. Actually, I have 2 slides, I believe, or 3 slides, but that's it just to get started. I love this this theme that they've come up with. Anyways, this is the manual update versus fully automated. So what I'm going to show you today is some ideas around automating taking a monthly update for F&O. So specifically, if you look on the left side, typically, and of course this will be different for specific implementations and customers, but in general, you start by updating or creating a specific environment with the update so you can at least check what's going on. If there's nothing funky going on, you'll likely be running some tests on there, either manual or automated. You verify those. You need to get sign-offs from specific people. And then you start rolling this out to other environments as well, right? You have a test environment, you have a UAT, you have development environments. All these things at some point need to get updated in a specific order that works for your company. Updating all the development environments, of course, it kind of depends. There are customers that have lots of development environments. You may only have one. Maybe you have an ISV or a partner that you depend on, but still, for larger organizations, there may be a lot of rollouts going on, not just test environments, but development environments as well. And then, of course, towards the end, typically, you update your build process as well, whether that is the traditional build VM that you can get through LCS or the actual new build process, which if you have not heard, there's actually a link in this slide deck at the end if you want to start playing with that, but it uses NuGet, and I'll show you that as well. So all of this is kind of in some combination is typically what people go through when they're taking a monthly update. So on the right column, what we're going to do with automated is pretty simple. You create an Azure DevOps ticket, you assign it to the automation user, and you sit back and relax. How's that? So sticking with the theme, I think we have a little knockout, hopefully, by the end of the session. So before I get into a few more details, I'm actually going to kick off the workflow that I have because if I've timed it correctly, we should actually be able to get it all the way through by the end of the session. While I'm talking, we'll just let it run. Okay, so I'm going to go through this pretty quickly. This may be a little confusing at first, but when we take an update, obviously there's a couple of things we need to do. We have the asset library. If you go to one of your environments and you see the quality update, you have to click it, and then it creates a package in your asset library. So in this case, I have the deployable package here, and I'm going to update my environment from PU35 to PU36. So what I need to do is I'm actually going to gather the IDs of what it is that I'm going to deploy, right? Those are the only pieces that I need. I'm going to supply in my work item, and everything will flow from there. So I need this, and then the NuGet packages, which I'll talk about in a little bit. This is for the new build pipeline. So same thing here. And I've cheated a little bit. I've skipped the application just because it's larger and I wanted to get through this whole demo. But in any case, same thing, you copy paste the asset IDs. So moving on, I actually have created a custom work item in Azure DevOps called the monthly update. And I have aptly actually chosen the gift icon because the monthly update is a gift from Microsoft to you. Yes, it is. I'll stick with that. The update is here. So I've added a couple of custom fields. There's a compiler, package, asset, platform, application. This is for the build process. And then this is actually the ID of the update package of the binary update itself that we need to apply. And then I give it a fancy name. This is just for tracking purposes. So the way this works, and I'll already show you a little bit behind the scenes, I actually have a Power Automate flow, and I'm just going to put this in test mode so it'll go through quickly. I'll go through this again later to show you in detail. So I've put all these details in. All I'm going to do now, you see I'm ready to go. I assign it to my service, and I hit save. And I'm quickly going to go over here, and you should see in a second here that there we go. There's a new release that just kicked off, right? So we'll let this go. And let me just quickly flip back to the last slide that I have here. There we go. So how are we really going to do this? So like I said, I've customized an Azure DevOps work item with a couple of extra fields of metadata that we need. To actually kick off the Azure DevOps pipeline, I'm using Power Automate. It's a really simple Power Automate flow. It gets triggered when you assign that ticket to that code service, and then it just goes straight into Azure DevOps and kicks off the release pipeline. It's a standard flow. It's super easy to create. Next up is the release pipeline itself in Azure DevOps. So obviously we're using the LCS tasks. If you haven't played with this, this is release pipeline tasks to upload packages and deploy packages. I'm actually using a small preview feature here that should be out pretty soon. So I took the purview of actually using it here because with a little bit of luck, it'll actually be out by the time this airs. There's something called Azure DevTest Labs, which I'll be using, and I'll talk about that in a little bit as well. So I'm using tasks in Azure DevOps for that. I have a couple of PowerShell scripts, and then we're actually automating RSAT as well. And then on the DevTest Labs, I'll explain it in more details, but I'm using a custom image and something called artifacts. And that's pretty much it. I've listed this here just in case you want to go back later. You actually see all the specific item points that I've used. All right, so let's flip back here. So and let me show you this first. The new build pipeline, the way the pipeline works is actually, and I'm using Git here. I'm sure I'll get comments about me using Git. But in any case, the way this works is the build pipeline has a configuration file with NuGet packages. So the point is you have to get these NuGet packages, upload them to your Azure DevOps under the artifacts branch for a specific version that you need. The build pipeline will then actually use NuGet, and this is a standard NuGet file, to get the correct version to build against. So obviously, when we have to take a monthly update, we need to get the new NuGet packages from LCS, upload them here, and then change our code base to say, I want to use this new version. We're using Git here. So Git has a concept of a pull request, which means when you do a change to any of the code, including this config file, for example, you send a pull request, somebody approves it before it goes in. So what's happening here, and this will be step one. So let's dive right into the release here. Step one is actually getting the latest NuGet files. And before we continue, I'll kick this off. Get back to that later. There we go. So the way this works, this actually uses a new task, which will be out soon, to download something from the LCS asset library. And so in this particular flow, it downloads the NuGet packages. So remember, we specified these asset IDs in the work item ticket. It'll go grab those from LCS and actually push them into your artifact repository. So it's a NuGet push. Once it's done that, there's actually a little script in there that creates a new Git branch and sends a pull request to update your code. So let's go look at that. If I go to my repos and pull requests, you see it actually created, it's 2 minutes ago, created a new pull request. If I go in here and look at files, it's suggesting that I update these this version to the next release. So there we go. So all I have to do when I'm ready is approve, and it'll go into my code flow. But obviously, we'll wait for that. The other thing that's happening here, which is very interesting for the monthly release, is as part of the PR, you can set a build policy to say this pull request is not allowed to go in until we actually have done a successful compile. And that's what this required check is. So if we go look at the view check, you see that there's actually a build succeeded on the DynamicsCon PR. So again, let's open it in a new tab. So this is the build. And you see it successfully ran. Here's the build itself. For those who've don't believe me or haven't seen this, but this is the X++ compile. And of course, what we want to check and what I want to show you, this may be a little small, I don't know, but it's actually using this new version of the NuGet package. So even without actually checking in this change, it obviously compiled my code. So I know my code is now compiling correctly against the new version, and I'm ready to go. So that was part of that first step on the pipeline, which is getting the latest NuGets. So this is all just sitting there compiled. Anytime I hit the approve on the PR, this will go in. And from then on forward, all my builds are going to start using these new NuGet packages. All right. So the next thing we obviously want to do is we want to actually test this new code. And for that, I'm going to flip over here. This is the Azure portal. And Azure has this new feature called DevTest Labs. DevTest Labs is really a way to allow any users, and of course it's geared towards developers specifically, to create VMs. So as a company, as a manager, I can supply specific images they can use to create new virtual machines. And I can actually set quotas. By default, they will automatically shut down. You can even also set them up to automatically start, so I can control the costs of these VMs in Azure. So there's all sorts of cool things you can do. But what I'm using here is actually something called, and let me scroll down, custom images. So what I've done here is I've actually taken the VHD that's for download on LCS. I've extracted that and uploaded here as a base image. Now, there's a couple of things to keep in mind. You probably want to do some things to that VM security-wise. For example, you want to change that administrator password because putting that on the internet is clearly not a great idea. So changing the password. I've turned off a couple of features just to like management reporter, for example, things that will just slow down the VM and I may not need immediately. I can always go in and turn it on. I've had to install like an Azure VM agent. Anyways, I'm planning to do a couple of blog posts to go into details on this because clearly there's no time in this session to go into all of the little details that make up this demo. And again, my goal is here to get the gears going and hopefully you can come up with your own flows. But I do plan to actually document some of the deep details of what I've done. But in any case, I've created this custom image. And what this allows me to do is to actually go and create my own image as a user against my quota and such and such. Now, what the build automation is actually doing, and I think if I hit refresh, there we go, it actually creates one of these automatically. So if we flip back to the flow here, so this is going to create a test VM. So obviously first, it is going to spin up the image I already have, but then I am actually going to run a script that installs the update. And this is still going, so we can flip to what this looks like here. So I'm using these tasks that exist. They're Microsoft preview you can get from the Azure DevOps Marketplace. So it's going to create a VM. I need to save the ID of what it created. We'll get back to that later. And then as part of this, it actually installs an Azure DevOps agent on this VM so that I can actually run things on this through a pipeline as well, which is what I'm going to do next. It creates the VM, which is doing right now. I'm actually going to download that binary update, the one that we specified on the work item. It's going to download it on this VM. It's also going to grab the latest code package from my build, which I didn't show. I'll go back to that. And I have just a couple of quick PowerShell scripts here, which, as you can say, they're actually commented out. And I guarantee you these work, but I've commented out just for the sake of speed for this demo. But all this does is it grabs that zip file that we get from a build. It downloads it here. Well, it actually gets it through Azure DevOps automatically. And then it unzips it, and then it just runs a dev install. Next thing, it does a similar thing to the package. So it downloads here from LCS, and then it comes here. It's going to extract the zip file, and then it's going to run the quick install all. Note that this dev install doesn't do DB sync and those types of things. There's no point in doing that because this install update will take care of all of that. Now, this whole process will take a while. Obviously, installing an update on one of these VHDs probably takes about, 45 minutes to an hour, depending on what kind of resources you used for the VM in Azure. You can make it faster, of course. But I think in my demo, and I'll show you a previous demo that actually succeeded. We can kind of look at the timings of each of this. But this is going to install the update. So after this is all done, we actually have a brand new VM with whatever database is on there, which you could easily add another step in here if you want to restore a database, or you can put a database in the standard image that you supply. It's up to you. But in the end of this work stream, we actually have a fully working VM with the latest update, assuming that there's no issue with the update, of course. But if there is, that's likely going to be an issue with the update itself, unless you have some custom code problem, of course. But again, you can go look at this. So that will create a temporary test VM. Next up, it's actually going to run some tests. So in this case, it hasn't yet started, but we can look at the tasks. It's actually going to run RSAT. I'm currently using a PowerShell script, but I believe there are some features in the pipeline to have standard tasks in Azure DevOps for this. So keep an eye on social media and whatnot on RSAT, because I know they're working on these things. But for now, we're just running the RSAT tests here. So that does mean once this VM is created, we can run tests. Now, the reason that I've put this in a separate box here is that in case any of the tests fail or there's some sort of an issue, you can actually start working on this VM to try and resolve what's going on. And then potentially, if this fails, there's like a redeploy button. So if this fails, you can keep trying and fixing things until you feel comfortable, and hopefully you can move on. So, okay, so at this point, where we are is we took care of the code. It's waiting for us to actually put in the new NuGets and use those going forward. We'll actually have a new VM, a one-box VHD, that will have our code. It will have the update, and it will have run RSAT tests against that. Once that's done, and you can see these little boxes here, these little icons with a person, these are approval steps. You saw me approving at the very beginning, so that'll kick off. But once these RSAT tests are done, and I feel good, I can actually click the approve button. When I click the approve button, a couple of things will kick off. One is it'll actually go and deploy this update to my LCS environment. In this case, it's going to deploy to a tier 1, but clearly, if you know the tasks, you can specify whatever you want. And then once this one's updated, there's another approval step that will then update, for example, my UAT, right? Again, these are just samples, but should be clear what's going on. Then next, what I can do is an approval step, because it'll keep this VM around, but once I approve the step, it'll actually clean up this VM and delete it. The reason why I put in an approval step, because maybe even though you're rolling this out, maybe you just want to keep this environment going for a while longer. So there's an approval step here where you can actually go in and then say, okay, I'm ready to just remove this VM, and it'll clean it up nicely. One thing to keep in mind, like I said, DevTest Labs by default turns off these VMs, and you can create schedules and all this sort of thing. So it may be automatically shut down already. I'm not sure if there's ways to prevent that when you create it. That's quite possible. And then finally, and I'll admit this step I have not completed, but it's something that I would love to actually get done. There's actually an option in DevTest Labs through this API, and I'll show you this. So in this case, I actually want to create a new VM again, so that it's vanilla after, I don't want the RSAT test data or whatever on it. It's going to create a brand new VM, but you can actually then, once the VM is done, you can create a new image. So the idea being that once you've approved it, it will actually, and remember when I say you have these base images, when I try to add an image, I can actually pick of these custom images. So what the step is supposed to do, again, I didn't get to finish that, but it will actually take that new VHD it created and convert it into a new image. So that going forward, once you've approved it, your developers, your consultants, your users can actually come in here and create a new VM of that new version. You can do all sorts of crazy things with that. Again, you can maybe download a newer version of RSAT, or all those types of things you can do, and then just have that image created automatically. So that's what the step is for. All right, this is in progress. So let me show you the DevTest Labs here, right? So we have, as part of the image, I wanted to show that. So we have the VHD image, which is a custom image. So this image essentially works with ARM templates, the way it gets deployed, in case you're familiar with that. If you actually add an image, like most features in Azure, when you go through the manual steps, in the end, you can actually have it show you the ARM template, and that's then what I've used. But what's interesting here, sorry, this is adding a new custom image. That is not what I wanted. I wanted to actually add a new virtual machine. There we go. So you choose a base, which is the image I've uploaded. And the way this works, you just upload the VHD file, and then you add it as a custom image. That's it. But what's interesting here is I choose a base, and then this is what we do in the automation piece, right? So first of all, you can pick virtual machine sizes. What I've been using here, I think, is the B8MS, mainly because it has a lot of CPU, a lot of RAM, and it's burstable in the sense that if you use it 24/7 at high CPU, you're going to get throttled. But in this case, we're only going to be running this VM for a couple of days, maybe. We're definitely not going to use it 24/7. So this should suffice. But again, this is all about cost and how to manage that. So you pick a VM size. One of the things I always do, because purely for speed, is just putting an SSD on there. It makes things a lot faster. And especially when you're doing this automated flow, right? You want this update to go in quickly. It's a lot of disk access because the update is large. There's a lot of file copying, so it'll definitely make a difference. But what I wanted to show you here, there's something called artifact selection. I've not added anything custom, although I'm thinking there's some interesting things you can do with that as well. But the artifact selection actually has Azure DevOps features. So as part of the artifacts, there's these things. You can, I clicked too quickly. I have to do it again. Hold on. Go back, choose the base, add the artifact. There we go. Right. So there's 3 here related to Azure pipelines. I'm using the deployment group agent, but you can just do a regular pipeline agent. And this will actually, as part of the deployment on Azure, will actually create an Azure pipeline agent or a deployment agent on the VM as part of the deployment. And the interesting part of that, of course, is then all of a sudden Azure DevOps can start orchestrating things within the VM itself. And that's how you can, for example, run RSAT tests if you want to do it on the VM. Or like what I'm doing, I'm installing the packages. Now you could create your own artifact here so that Azure actually deploys and runs these scripts. But I've chosen to just make it flexible for myself, add the Azure pipeline agent, and then I can orchestrate everything else from Azure DevOps itself. But there's all sorts of cool stuff in here, as you can tell. You can create your own Azure artifacts, which I think is as simple as having something in a Git repo in Azure DevOps, and then you can plug it in here. There's plenty of documentation on all this stuff, and I think this is a relatively new feature of Azure. So there's more and more things being baked in here as well. So that's on the artifact side. Let's go back here. So the virtual machine is still deploying. All right, let's go back to pipe. So this is in progress, running the tests. So I want to talk about the build for a second as well, because I think there's probably some sessions about this at the Dynamics conference already. So make sure to check those out. For the PR though, we're doing a similar thing. We're running the pipeline, but same to this. The goal of this whole session is to get you think through putting things together and using all of these features essentially as Lego blocks. The new pipeline itself can be used as Lego blocks as well. If you look at what the pipeline does compared to the old build VM, where there were a lot of PowerShell scripts, right here, they're actual explicit steps. And notice that, for example, in this PR build, so this is the build that runs when there's a change, a pull request being submitted. It doesn't create a package. There's no point in creating a package. I just want to make sure the code actually compiles. There's interesting things you could do here. Maybe you could run tests potentially, depending on your setup. You can't run the tests inside of Azure DevOps. You would still need a build VM to do so. But you can definitely use this new build pipeline on build VMs as well. It doesn't really matter where you run it. Because it grabs the latest versions of the NuGets, so the specific version of FNO for the builds, all of that's taken care of. So again, here, it's Lego blocks. Think of all of these features as Lego blocks, right? So a couple of things that are not in this pipeline that I thought would be interesting to add and to think about is really data management, right? One of the things is, I know of a lot of customers who like to have custom databases on development VMs, or for sure to run your RSAT tests, you want to have some sort of a known data set that's likely, well, not likely, almost certainly your actual data set or your actual master data. There are APIs, of course, now in LCS where you can do data moves. Now, to get that data to actually come onto a tier 1 VM, that takes a long time, and I know that it can be error prone. Now, that said, you've also seen me adding a lot of PowerShell. One of the things I did not use here, but I encourage you to investigate if you're going to do more PowerShell, is there's actually a GitHub repository about a community called the D365 FO tools, and it's a whole PowerShell library that has just simple PowerShell commandlets to install a package, to set up a database. There's all these different things. So if you start thinking of combining that feature, yet again, as a Lego block into this flow, you can start seeing how it all comes together, right? So there's interesting things. For example, here, I'm deploying to UAT, or this could be a tier 2 as well. You can use the database movement API to say, look, before I apply this latest update, let me just grab a new copy of production data. Other things, which I think I've talked to a couple of ISVs who've done this, is actually have a pipeline that uses FNO data packages to create a brand new SQL database. So let's say you have a blank database backup, right? You can have a flow here that imports the blank database, runs a couple of data imports, right, to create a new data set. And maybe those data packages you source control, right? Create a new SQL backup, right? take the backup, store it in Azure Blob, or you can use a standard SQL feature to back up straight into Azure Blob. And then maybe as part of this test VM creation or part of your tests or part of your deployments, you can restore those databases as well. It's all scriptable, right? And much of that has nothing to do with FNO, which is another key takeaway, right? Many of these, of course, deploying to LCS and downloading a package are very specific, but everything else is, if you learn about Azure DevTest Labs, you can figure out how to use the VHD. If you learn about SQL, you can figure out how to use blob storage to back up or store, combine the whole thing and put everything together. That's really the key piece of information I wanted to get out there. So ultimately, this is still running. I think we have, there's about 8 minutes. So let me show you some timings because we had some delays here. Let me show you the timing of a previous run that I've done. So my previous one here, and again, I have turned off a couple of features, but to show you that. So here we have, boom. So creating the VM itself, this says 11 minutes. I've seen this fluctuate anywhere from 5 to 15 minutes. I'm sure it has to do with Azure, somehow being slightly different, or a data center or disk drive you're using, whatever. So if it's roughly between 5 and 50 minutes to just spin up a new VM. What it actually does is it boots it and it waits for the Azure VM agent on the VM to react. So typically spinning up the VM is maybe like 6-ish minutes, but then for the VM to actually be completely responsive to Azure, that adds a bit of time as well, and that adds to this timing. And of course, this VM has SQL on there, which takes a while to load. I have turned off a bunch of things, and I encourage you, if you want to play with this, to do that as well for the VM. You want to turn off the batch server, right? You do not want that batch server to start spinning up, especially if it has a lot of backlog. If it hasn't run for a while, it may actually start trying to catch up. Windows updates, make sure you stay up to date with Windows updates, because otherwise the first thing a new VM will do is start downloading Windows updates, and it'll clog your disk space and it'll add latency to the startup. So think of all these different things and what you can do. The one also key piece that I had to do to make all of this work is you have to install what's called the Azure VM agent on this VM before you put it in DevTest Labs. Otherwise, Azure is unable to communicate. It can't deploy your artifacts, which means you don't have a deployment agent and all those types of things. So you have to kind of think through a little bit what needs to go on this VM. In fact, a couple of other things I've done, since I'm talking about this anyway, I have increased the disk space because I figured, after everything's said and done, that VM only had maybe 20 gigabytes left. So I was thinking, well, if it runs a couple of Windows updates, and then I'm going to download a binary update, it's just gonna. So I increased disk space to make sure that that's not a blocker. So there's all sorts of things. I've installed Visual Studio Code. I installed Microsoft Edge. So you can kind of make it nice and easy for anyone who's actually going to use it. You can pre-install RSAT. Of course, you need to think about keeping it up to date, but think through of what would make your people productive, right? And again, maybe you can automate all of that as well, since you can create images. So that's what this is. It takes about 11 minutes. And then this is what the deployment group looks like when it's done. Again, this has actually, I've turned off a bunch of stuff. So these are drops from from Azure DevOps itself. So don't worry about that. This one is actually my custom code. So it downloads my package from my last successful build automatically. So it got that. This one took 5 minutes. This one was actually completely turned on. This was actually downloading that binary update package from LCS. So of course, since this is cloud to cloud, downloading that package, which is probably 2 gigabytes. I'm not entirely, 1.5. I don't know. Took about 5 minutes. One thing to consider here, all VMs in Azure, well, depending on the SKU, they get a temporary disk drive that's SSD and super fast. So I downloaded there. And then my PowerShell scripts, yeah, and these are, these I've just commented out as you saw earlier, but these are actually to extract. And I think this one took 7 minutes because I actually left the extracting the package. So extracting the binary update took about 7 minutes, but then actually applying it probably takes another hour is my guess, 45 minutes to an hour, depending on what resources you picked. So all in all, getting all of this done, I think installing the update will take the longest. So you're probably looking at about, let's say, an hour and a half to get this whole new VM spun up with the latest update installed on it. And then going back, RSAT doesn't take very long. I mean, this one is just a silly, simple test we've added just for the sake of having one. See, there's just only one test here that ran successfully. That took 52 seconds. But clearly, this completely depends on what you're doing in your tests. And that's it. Everything else is things we've already seen, right? Updating environments in LCS. Again, depends on the environment, anywhere from 30 minutes to an hour, probably. So this whole flow is actually pretty nice. Sadly, I think this got hung up a little bit and it's not completed, but pretty much that's the flow. Yeah, I think that's what I had. So that concludes this demo. So thank you very much for watching. I hope that I've inspired you to think through these things. Like I said, this conversation is not done. I had so much fun putting this together. I'm really looking forward to your feedback, your questions. I've already reached out to some folks, including Mods, who owns the FO tools, Kenny Solon, who actually helped me with RSAT. We want to do a couple more. So hopefully this is a beginning of something that everyone can contribute to and we can all kind of look together. So thank you very much. Feel free to reach out to me on social media, which the DynamicsCon website, I believe, has links to my Twitter and LinkedIn. So go check that out. Thank you for watching. I hope you've enjoyed it, and let's keep this conversation going. Thank you. Stay tuned for the Q&A with me.